Hello everyone, today is day 37 of solving a LeetCode problem every day, and today I'm going to be solving isomorphic strings. So given two strings s and t, determine if they're isomorphic. Two strings s and t are isomorphic if the characters in s can be replaced to get t. So all occurrences of a character must be replaced with another character while preserving the order of characters, and no two characters may map to the same character, but a character may map to itself. So here we have egg and add. So we can replace all the e's in egg with a's and all the g's with d's, which would turn s into add, which is why the output is true. So yeah, as I said earlier, so you can map the e's to a's and map the g's to d's. Here we output false, and the reason why is we can actually map all the f's to b's, which would match up the characters in the way that we want them to match up. But here we have two o's and here we have two different characters, and we can't map o's to do, we can only map a single character to another single character. We can't map a single character to multiple different characters, which is why false is returned in this case. Now here our output is true because p's can be mapped to t's, a's can be mapped to i's, e's can be mapped to l's, and r's can be mapped to e's, which gives us title for both strings. So the way we're going to essentially solve this is by creating mappings from string s to string t and creating mappings from string t to string s, and we're essentially going to validate those as we're creating these mappings. We're going to validate them as we go and ensure that we don't get any duplicates. And if we do get any duplicates, we can return false. However, if we can create the entire mapping and get no duplicates, we can just return true. So we're going to start by creating two dictionaries. So this dictionary is going to map from s to t. So we're going to say s to t is a dictionary, and we have another dictionary that's mapping from t to s, which is going to be t to s is equal to another dictionary. So the next thing we're going to do is we're going to check if the length of string s is not equal to the length of string t, and if this is the case, we can return false, because for two strings to be isomorphic, they must be of equal length. Next, we're gonna start a while loop, which is gonna loop through the range of the length of s, and within this within this for loop, we can do processing for both string s and t because we've already validated that they're of equal length. So we're not gonna get an out of bounds exception for either string. So what we're gonna do is first we're gonna say mapping from s is equal to s to t dot get the current character from string s at index I or -1. So what we're doing here is, first of all, this is going to return some character from string t or -1. So -1 is returned if no mapping is already exists. So if the key s of I does not exist in the dictionary yet. And we're going to do the same thing for t to s. So we're going to return some character from string s or -1, and it's going to be mapping from t is equal t to s dot get t of I or -1. And so here we're passing in s of I is because s of I is going to be our key since we're doing mappings from s to t, and here we're passing t of I because we're doing mappings from t to s. So our keys are going to be some character from t to I. Now the question is how do we know if we're encountering a duplicate matching? And the way we can know that is if this mapping exists, so we get some character that's returned that is not -1, and it's not equal to the current character that we're at. So like for example, imagine we're looking at the string, let me try to come up with a good example. Let's say string s is equal to egg, and let's say string t is equal to, so what would be a good example in this case? Let's see, mapping from s to t. So we want to find a mapping something that already exists. So maybe this wouldn't be a good example. Or I guess we can try like e. So we want to map this to maybe like, so foo was the So there's egg and there's add. But let's say let's say this was like map. So here we can say, so when we're creating these hash maps, so we can say that E maps to P, and then we can map G to A. But once we're in this iteration with G and P, when we do this mapping from S, this is going to return st of t dot get. So the s of I is currently going to be G, and we've already mapped G to A. So this is going to return A right here. Mapping from S is going to be A. However, since this mapping from S doesn't equal to P, it equals to A, we know that G has already been mapped, and we can't have duplicate matchings, or duplicate mapping, sorry. So in that case, we can just return false. So we can say if mapping from S does not equal to S of I, and mapping from T does not equal to, I might have these, do I have these? Yeah, so this is actually supposed to be S of I, this is supposed to be T of I. The reason why this, because mapping from T returns something from S, and mapping from S returns something from T. And in this case, we can return false. However, there's one thing we're not keeping into account with just this right here, and it's the fact that either of these can return -1, and that's if the mapping doesn't already exist. So what we also want to say is and mapping from S does not equal to -1, and mapping from T does not equal to -1. So basically, if mapping from S is equal to -1, this is going to return false. And if mapping from T does not equal to -1, if mapping from T is equal to -1, this is also going to return false. And since we have two falses in here, this would end up as a false, and we can just skip this whole entire test case. So basically what we're checking for is if both of these mappings from T to S and S to T have not been made, and if they both haven't been made, then we can just skip this whole condition right here. However, if either one of these are not equal to -1, this would end up as true, and we can return false in this case, since the mapping has already been made and we can't have any duplicate matchings or mappings. So here we can just say else, we just create the mapping. So the current character at S is going to be equal to T of I, and T to S is going to equal, or at T of I is going to equal to S of I. And finally, if we go through this whole entire loop, create all the mappings, and no duplicates have been found, we can just return true. So if I now submit this, we pass all the test cases. So the time complexity of this is going to be O of n, so it's going to be linear time, and the reason why is that we're processing each character just once, since we're just looping through all the characters in each string. And then the space complexity is going to be linear also, since we're storing all these mappings in the two dictionaries. So yeah, that's the solution for the day.